There's a fan back there. You can put the fan in. Oh, we're recording. All right. Get some notes out. The title of our notes is Adding and Subtracting Rational Expressions. Example 1. All right, we are going to add 6a. Hey guys, we've already started, so I shouldn't hear any talking. 6a over 3b plus 4a over 5. And there's a lot of this problem you already know how to do. So you already know how to get a common denominator. You need to do that. You already know how to determine what each fraction needs, so you can do that. And you already know how to fix each of the fractions so they have the common denominator. So I want you to go through all the steps that you already know how to do. It might be that the other pencil sharpener works better. Okay. One of them works better than the other one. What does the first fraction need? Needs 5. 5 on top, 5 on bottom. What does the second fraction need? 3b. So what are the new fractions?
30a over 15b.
Over 15b. Plus
12ab. Let's go.
Over
15b.
15b. Okay. And then the past couple days we would have stopped there, right? We would have said we were done. So what I want you to do today is to take that, write it as one fraction. So the common denominator for the fraction is 15b. And then this is an addition problem. So what should I write on the top? I've got 30a plus 12ab. And they are not like terms, so I can't combine them. I have to leave it like that. And then before we started adding and subtracting, we had 2 words that we wanted to remember when we were doing the first couple days of the unit. Do you guys remember? Factor, cancel. So at this point, we have moved back to the very beginning of the unit when we're simplifying the problem, and what we have to do is factor and then cancel. So can you factor the top or the bottom? Yes. What type of factoring is it? GCF, yeah. So what's the GCF of the top? Yeah, I was going to say bigger than 3, right? 6, okay. And then what else? A? Mm-hmm. So I take out a 6a, and what's left over?
5 plus 2b.
Okay. Now that parenthesis is going to have to stay. There's no way the 5 plus 2b can cancel with anything because it would have to have a set of parentheses that are identical to it, and it's the only one. The a on the top and the b on the bottom, those are different variables, so definitely they can't cancel. But what about the 6 and the 15?
3.
Yeah, you can divide 3 out of both of those. So 6 divided by 3 is 2. 15 divided by 3 is 5. So your final answer is 2a times 5 plus 2b divided by 5b. So that is... Say that again? I divided by 3 and left a 2. And I divided by 3 and left a 5. So that is the whole process from start to finish. That is how we add or subtract rational expressions. The whole thing. All right, how are your brains feeling? Logical steps there? Make sense? Okay. Example number 2.
So these hashes get harder because I want that hard.
Yeah, the bottoms that are, the denominators that are monomials, where it's just one term like that, those are pretty easy to handle. It starts to get a little bit more complicated when you have binomials and trinomials on the bottom. Just for you to prepare yourself mentally for how long we're going to take notes, we have 4 examples. Okay? We have 4. All right, this one's going to be 4y over 4x plus 5x over 2y. So I want you guys to go ahead and do the stuff that we know how to do. So we're going to find our common denominator. Make sure, sorry, that's 2y to the third. Sorry, missed it. Get your common denominator. Figure out what each fraction needs. Fix the fractions so that they have the denominator. So what did you guys say that the first fraction needs? Y cubed?
Oh, I didn't put the guess. I didn't put the.
What does the second fraction need? The second fraction needs 2 and an x. So what is your first fraction now? Over. And what's our second fraction?
4y cubed x.
You can do y cubed x, that's fine. Okay, second fraction is? Okay, and then our next step is going to be to put it all together as one fraction. So what should we have on the top? Okay, and then what do we do at this point? 2 words, right? Factor cancel. Factor cancel. So what could we factor?
2.
Yeah, we have a GCF of 2 on the top. And what is left over?
2y.
2y.
Did we take an x out?
No, only because the x isn't common. Yeah. Different variables. So 2y to the 4th plus
5x.
And what do we see that could simplify? Yeah, the 2 and the 4. What about any of the letters?
Y.
No, because they're in parentheses, right?
Yeah, this one is in parentheses, right? So the parentheses cannot be touched. Unless we have another set of parentheses that are identical, you can't touch them. And so once you ignore those parentheses, then the bottom variables have nothing to cancel with. So the 2 and the 4, we can say 2 divided by 2 is 1. 4 divided by 2 is 2. Now, since the top set of parentheses have a 1 in front of it, you can drop the parentheses and just write the top out. So we got 2y to the 4th plus 5x squared. And then 2xy to the 3rd. Now, if I see a 2y to the 4th and I see 2 and y to the 3rd, why can't I cancel any of that stuff? Well, it's different exponents, but that's not y. No.
cross over in the parentheses.
Yeah, it's the plus, right? The top is being added, so that means that if we try to cancel stuff, we're canceling addition with division. Can we cancel those?
No.
No, we can't cancel those. So it's with the top, it's either the whole group or it's nothing at all. Okay. All right, so we are done. That was it. Okay, are we ready for some more difficult denominators?
No, but yeah.
Not really. Now, you don't have to want them, but I think you guys kind of found this one to be boring. You're like, yeah, we can do that.
I just forget the fact. I'll do the rest.
Example 3. 2 more examples left. Example 3. We're going to do 6m over 3m plus 3 minus 2 over 5m to the third plus 5m to the second. So go ahead and figure out what your common denominator is. Fix your fraction so that it has the common denominator. So what did the first fraction need? 5m squared. What did the second fraction need? 3. So what is the first fraction now?
That's 5m squared.
Yep, 5m squared. So this is 30m to the third.
What's that 3 on the bottom? Yeah, no. Over.
So this is 15m squared times m plus 1. You meant this 3 over here?
Yeah.
That was, we just saying we were multiplying by 3 on top and bottom.
Oh, okay.
And what's our second fraction? 6 over... Do you guys remember why we leave the denominator factored?
It just makes it
Easier to cancel.
Makes our life easier. It's going to make it easier to cancel when we're all done. You guys in the back paying attention? Because you've been real chatty. All right, let's go ahead and write it as one fraction. So 15m squared times m plus 1. And what should I have on the top? Okay. And what is our next step? Factor, cancel, right? What type of factoring do we have? GCF?
You can take 6 out, right?
And take out a 6. Yep. Are the parentheses going to cancel at all? Nope. They're not identical, so they have to stay. Does anything cancel?
You take the 3.
Yeah, the 6 and the 15 both are divisible by 3. So 6 divided by 3 is 2. 15 divided by 3 is 5. Does anything else cancel?
No.
No. So we're done.
All of them.
I did.
Not yet. That's a minus, not a plus.
All right, 3 over n squared minus n minus 20. Subtract n minus 4 over n plus 4. I'll do the easy one. N plus 4.
Oh,
You're welcome. Always trying to make your lives easier.
thank you. I gotta use the bathroom so bad.
I don't sound sick anymore, right there.
And I think,
Four negative 5?
math is so fun. Totally.
So what's our common denominator? So does the first fraction need anything? No. Okay. So I'm going to go ahead and just rewrite that first fraction. And I'm writing the denominator in the factored form just to make my life easier later. What does the first fraction need? Or the second one, sorry. The second fraction. N minus 5. N minus 5. Now, what do you notice about that second fraction? Now that we have the n minus 5 there. Yeah, we have to FOIL it. Do you guys see that? Because you have n minus 4, and the n minus 4 is being multiplied by an n minus 5. And we gotta multiply it all out because the tops, the numerators have to be combined. To be able to make this into one fraction, you have to combine like terms in your numerator. So we do have to multiply those out. So how do we go about foiling that? What are we going to get?
Can't you just look at the original comments? Or the original denominator?
It's almost the original denominator, but not quite.
Negative 5n.
So n times n is n times negative 5. Negative 4 times n.
Why are they both negative?
Because you had n minus 4 at the top to begin with. And now you're multiplying it by n minus 5 to get that common denominator. And then negative 4 times negative 5. So that means that this fraction is n squared minus 9n plus 20. And we have n plus 4 and n minus 5 on the bottom. And now we're going to go ahead and make it one fraction. And there's something else about this problem that could trip you up. Does anyone know what it is?
No.
It's not a fraction. Oh, it's subtraction. It's the minus sign in the middle. Why could that mess you up? You have to distribute it. You have to change everything.
Jesus Christmas.
So minus n squared plus 9n minus 20. So you have to watch it in subtraction problems. You got to make sure that if there's more than one thing that's being subtracted, that you actually subtract all of them. A lot of students would miss that, and then their answer would be wrong. They get everything right up until this, and then they mess it up at the end. It's very common.
Do you combine 30 and 30?
Yeah, we've got some like terms, right?
Yeah.
So what should we have now?
Negative squared.
Negative n squared. Okay. Do we like to leave the negative in the front like that?
Totally.
No.
We put it on the side.
We put it,
Well, like in front.
yeah, we put it in the front. We take it out like a GCF, right?
Mm-hmm.
N squared minus 9n plus 17. And then typically, What do we typically do at the end? What are the two words? Factor cancel. So the top, that's a diamond problem, right? We're looking for something that multiplies to 17 but adds to negative 9. Does anything multiply to 17 but add to negative 9? No. So that's kind of nice about this problem. Either one of these answers is totally acceptable because nothing cancels. So I would accept either of those. Those would both be full credit.
Nice.
And that's because if you were to try to do the diamond and factor it out, it wouldn't. There's nothing to cancel there.